Let us discuss chemical equilibrium sums. We will take the sum now. Calculate equilibrium constant. Calculate the equilibrium constant. Calculate the equilibrium constant for the reaction. Calculate the equilibrium constant for the reaction H2 gas plus CO2 gas gives H2O gas plus CO gas at 1395 Kelvin. At 1395 Kelvin. If the equilibrium constant at 1395 Kelvin or if the equilibrium constant at 1395 Kelvin or if the equilibrium constant at 1395 Kelvin or 2H2O gas gives 2H2 plus O2 2H2 plus O2 gas. K1 is equal to 2.1 into 10 power minus 13. Then 2CO2 gas gives 2CO gas plus O2 gas. K2 is equal to 1.4 into 10 power minus 12. Okay. Now, how to find this? How to do this sum? We will see. Now, here what is given in the sense we have to calculate equilibrium constant for this reaction. So, for this reaction, we have to find equilibrium constant. Okay. For this equation, we want to find equilibrium constant. Sorry. For which for this equation is given, for this equation equilibrium constant is given, for this equation equilibrium constant is given. So using these two equations, we have to go for this equation. So what is the required equation that we will see? What is the required equation? We'll see. So required equation is this one. This required equation we will get from which one in the sense from this one and this one. Okay. So required equation is this. This required equation we have to get from this and this. So this equation is the required equation. In this equation, hydrogen gas is there in the left side. That hydrogen gas is available in this equation. Hydrogen gas is available in this equation. So what we have to do? We have to reverse this equation. If we reverse this equation, then only we will go for this equation. Okay, so we have to reverse this equation. So let us reverse that equation. So on reversing, we will get 2H2 gas plus O2 gas gives 2H2O gas. Okay. What we have to do regarding equilibrium constant, that we have to see it. So we have reversed, but we want one H2. But here how many H2 is there? 2 H2 is there. Therefore, divide this equation by 2. Okay, let us divide this equation by 2. So we are dividing this equation by 2. Therefore, this 2 vanishes. Here 1 by 2 comes. Here this 2 also vanishes. So here we are writing 1 by 2. Okay, so we have reversed this equation and we have divided this equation by 2. So we got like this. Then we want this is the required equation. In the required equation, carbon dioxide is there in the left side. So that carbon dioxide is available from this equation. From this equation, we can get carbon dioxide. So let us take this equation as it is. So we are taking this equation, that is 2CO2 gas. So 2CO2 gives 2CO plus O2. Okay. So this is O2 is gas, CO is gas. Okay. Now this we want CO2 gas one time, but in this equation 2 times present. Therefore, divide this equation by 2. So let us remove this 2. So we are dividing this by 2. Therefore, here 1 by 2. Now let us add these two equations. On adding these two equations, what we will get, we will see. So what are the common terms that we will cancel? Half O2 cancel. Therefore, we are getting hydrogen gas plus CO2 gas gives H2O gas. Then this CO gas. CO gas. Okay, so we got the required equation, we got it. So then we got required equation for this. On adding these two, we got a required equation. So now we want a equilibrium constant for this equation. We want equilibrium constant. We want equilibrium constant for this equation. How to find equilibrium constant for this equation? For these equations, equilibrium constant is given. Using these equilibrium constants, using these equations equilibrium constants, we have to go for this equilibrium constant. So that means we should know equilibrium constant for this and for this. If you know equilibrium constant for this and this, then we will get for this. So what is the equilibrium constant for this one? That we will see. Okay. Now we'll see for this equation, this K1 is equal to, for this equation, equilibrium constant is K1. That is equal to this concentration of H2 power 2, this concentration of O2 power 1 by left side, what is the concentration of H2O power 2. Left side H2O is there. Left side H2 is there, that power 2 we have written. Okay, so K1 we got. Now for this equation, what is the equilibrium constant? We'll see, that is Kc is equal to, right side we will write in the numerator, right side we are writing in the numerator, left side we are writing in the denominator, that is H2 into O2 power 1 by 2. Okay, left side we are writing in the denominator. So now you see this Kc and this Kc. Here equilibrium constant you see, here equilibrium constant you see. You relate these two, this K1 and Kc you relate. Okay, so in order to get Kc from K1, what we have to do? This K1. Okay, what if you do K1, you will get Kc. This Kc1 you will get, that you think. So first one is we have to reverse this. We have to reverse this one and we have to take square root. Reverse this and square root it. Take square root. Then you will get this Kc1. Okay, so reverse and take square root. Take square root. Okay, take square root. So we will reverse. So 1 by K1 square root we have to take. Therefore square root equal to, so reversing H2O taking square root. So reversing, therefore H2 taking square root. Okay, so we got like this. Now you see this 1 by square root of K1 is equal to what? Is equal to Kc1, shall we say? 1 by square root of K1 is equal to Kc1, shall we say? So Kc1 is equal to this Kc1, this Kc1 is equal to 1 by square root of K1. Okay. So for this, so we know this equilibrium constant because K1 is given. K1 is given. So we know that Kc1 we know. Then we'll go for this Kc2. For this we'll see Kc2 is equal to, right side you write in the numerator CO O2 power 1 by 2 by left side you write in the denominator CO2. Okay, left side we have written in the denominator. This is Kc2. Now K2 is given. This K2 Kc2, what is the relation? That we will see. Okay, first we will write for this K2 will write. K2 we will write. Okay, so K2 is equal to what in the sense? K2 is equal to, right side we will write in the numerator. Right side is what? CO power 2, O2 power 1. Okay, it is right side. Now left side we'll see. Left side what is there? 2 times CO2. 2 times CO2 is there. That we will write. So 2 times CO2, therefore CO2 power 2. 2 times CO2 is there. So this is K2. Now we want to make this one and this Kc2 relation we want. We want Kc2. Kc2 is what? CO into O2 power of by CO2. It is Kc2. K2 is what? CO2 power 2, O2 power 1, CO2 power 2. Therefore, now you reverse this and take square root. And take square root. Okay. Reverse this one and take square root. Therefore, 1 by square root of K2 is equal to CO2 power 1, CO power 1, O2 power of. Okay. This is equal to what you see? This is equal to this Kc2. Okay, this Kc2 we got. Okay, you got Kc2. Kc2 is equal to what? 1 by square root of K2. Okay, so we know, now we know Kc1 we know, Kc2 also we know. Okay, Kc1 is equal to 1 by square root of K1 we got, and Kc2 we got as a 1 by square root of K2 we got. We know K1 and K2, therefore we know Kc1 and Kc2. Sir, now what is the question means? What is the equilibrium constant for this? For this reaction, for this equilibrium, what is the equilibrium constant? Kc we want. For this we want equilibrium constant. What shall we do? We know Kc1 and Kc2. How to get equilibrium constant for this? Now we got this reaction by adding these two. We got this reaction by adding these two. Now what is the equilibrium constant for this one? Using Kc1 and Kc2 we will see. Okay, first we will write equilibrium constant expression for this equation, that Kc is equal to H2O. Right side we will write in the numerator. Okay, left side we will write in the denominator. Left side thing we are writing in the denominator. Okay, so now we will see, left side we have written in the denominator. Now you take this Kc1 and you take this Kc2, you multiply these two, you will get this expression. If you multiply these two, then you will get this expression. Therefore Kc1 into Kc2, you multiply these two, this Kc1 and Kc2, you multiply it, then you will get this Kc expression, you will get it. Okay, so Kc1 is what? In the sense 1 by square root of K1, 1 by square root of K1 into Kc2 is what? In the sense 1 by square root of K2. Okay, 1 by square root of K2. We know K1 is given 2.1 in 10 power minus 13, substitute. K2 is given 1.4 in 10 power minus 12, that you substitute. So you will get the required equilibrium Kc, you will get so the required equilibrium, so for the required equilibrium, what is the Kc in the sense now this Kc2, Kc2 we'll see once. This Kc2 is equal to CO2 by COO2. Okay, so Kc2 is here. Okay, we have not reversed this equation. We have taken as it is. Therefore, we should not reverse this. Okay, therefore we should not reverse this. We will take as it is. So we'll take as it is. Therefore, square root of K2 will take. Kc2 is equal to square root of K2 we will take. Why? Because this equation, CO2 equation, we have not reversed. Just we have divided by 2. Therefore, we will take square root only. So if we take square root only, here we have to do, here square root of K2 only we will write. Square root of K2 only we will write. Okay, square root of K2. Therefore, Kc1 is 1 by square root of K1, Kc2 is square root of K2. Okay. Therefore, equilibrium constant is equal to square root of K2 by K1. So we are substituting K2 value and K1 value. K2 value and K1 value we are substituting. We are getting equilibrium constant. Equilibrium constant is this much. Okay. So we got a equilibrium constant for this equation. Let us go for next equation. Next equation is following two equilibria exist together that is 2a here K1 here K2 gives I, here K3 here K4 gives B plus C. Okay, show that equilibrium constant equilibrium constant for overall reaction, Kc is equal to K1 K3 by K2 K4, okay. Now we will see this one. Now we will take a first this 2a gives I, we will take 2a gives I. Here K1, this K2. What is K1? K1 may be rate constant for forward. K2 may be rate constant for backward. Like this we will take. Okay. Therefore, for this equilibrium constant Kc is equal to rate constant of forward by rate constant of backward, that is equal to right side concentration by left side concentration. Okay, left side concentration. Like this we got. So second part we will take. Second part is I gives B plus C. That second part we will take. I gives here forward K3, backward K4 gives B plus C we will take. K3 we will take it as rate constant of forward. K4 we will take it as rate constant of backward. So for this equilibrium constant is equal to rate constant of forward by rate constant of backward is equal to right side concentration in the numerator, right side concentration in the numerator, left side concentration in the denominator. Now we want overall reaction. So common terms will cancel. Common terms we are cancelling. So 2a gives B plus C. For this overall reaction, Kc is equal to concentration of B into concentration of C. Right side we have written in the numerator. Left side we are writing in the denominator. Now we will get this expression by multiplying Kc1 and Kc2. So Kc1 is what in the sense K1 by K2. Kc2 is what in the sense K3 by K4. So we got a equilibrium constant for this overall reaction. Let us go for next question. For the reaction, A plus B gives 3C. A plus B gives 3C at 25 degrees Celsius. At 25 degrees Celsius. A 3-liter vessel contains 1, 2,4 moles of 2,4 moles of A, B and C respectively. Moles of A, B and C respectively. Predict the direction of reaction if predict the direction of reaction if first subdivision Kc for the reaction is 10. Kc for the reaction is 10. Then B, Kc for the reaction is 15. Then C, Kc for the reaction is 10.66. Kc for the reaction is 10.66. Okay. So now first we will take the given equation